Good afternoon, sir, and good afternoon, all delegates. My name is Prateek Mishra. I am from IIT Allahabad, and I am a research scholar there. So, my topic of presentation is effect of sputtering process parameters on optical and dielectric properties of thin film indium selenide. So, we have taken a material indium selenide, which is a chalcogenide material, and we have deposited different thin films on with sputtering process with different process parameters, and we have seen the effect of those process parameters on thin films. So, this indium selenide is a chalcogenide material. Chalcogenide materials are the materials which have at least one chalcogen anions. Chalcogens means group 16 elements and one more electropositive element. So, these chalcogenide materials are a very attractive topic of research because of their excellent optical and electrical properties. So, recently these have been used in this GST and indium selenide has been used to make more efficient optical and optoelectronics devices. So, most of the work we have seen that to deposit indium selenide materials to know the properties of that is by thermal evaporation techniques or mechanical exfoliation techniques. So, we have just took the sputtering method of the deposition and have looked on the properties. So, phase change materials, some of the chalcogenide materials are also phase change materials. So, phase change materials are the materials which have different phases. So, we can transform to the different phase of that phase of that material by giving some external stimuli, like if we give some laser pulse or we give some electrical stimulation. So, we can change the phase of that material, and that phases of that materials have drastically different properties, optical and electrical properties. So, we can make tunable devices of that material. So, suppose that we have made a device of that material, we can tune them with the laser or heat. So, indium selenide material is a 2D chalcogenide phase change material. So, we have deposited different layers of indium selenide, different thin layers of indium selenide with sputtering, with different RF power and with different time, and we have annealed that thin films for different temperatures. So, why we have done this? So, we are making some devices. So, we have to know the behavior of those devices on these different sputtering process parameters. So, we have just deposit the film and have look on the electrical properties. So, first we have just characterized those thin films with the help of this UV-vis NIR spectrometer. So, from those UV-vis NIR spectrometer, we have got NK values of those different thin films. NK values, and we can see that absorption in the range of wavelength 300 to 1000 nanometer is good. So, after that we have characterized those thin films with the help of photoluminescence spectrometer. So, from that we see that the band gap of that material is around 1.25. So, this band gap of 1.25 have very good utility in the range of 700 to 900, which is a wavelength of the optical fiber communications also. So, photodetector application can be made. So, there you can see what 0.25 band gap of the material, and as this is a different as this is a phase and different phases material. So, different phases are also present in that thin films. So, they have some different band gaps. And after that, we took some electrical properties. We have employed a LCR meter to know the different uh, electrical properties like refractive, relative permittivity of that material. So we have made a MSM structure, and we just probe the dielectric constant of that material at different at different temperatures, starting from room temperature to 200 degrees Celsius, and at different frequencies, 100 kilohertz, 500 kilohertz, and 1 megahertz. So as the temperature increases, that relative permittivity is also increases, and when the frequency increases, that relative permittivity at as a fixed temperature decreases. So I'll tell you the utility of this work is we have different properties at different process parameters, and for a range of wavelengths. So we are simulating some photonic devices. So we in that simulator we have to get these nk values and these electrical values in that simulator. So we can use this data to model those photonic devices, and as well as if you want to model some metamaterials with this indium selenide material, you have this nk values, you can model those devices. So this work is supported by Science and Engineering Research Board, Department of Science and Technology, Government of India.